Good afternoon, everyone. I am from the AI lab of TAL Education Group, the biggest education company in China. Today, I'd like to share you Dolphin, a spoken language proficiency assessment system for elementary education. Oral language proficiency and verbal fluency is crucial for personal development. Studies have shown that it's better to improve and practice verbal fluency during school ages. But in many countries, like China, due to imbalanced ratio of teachers and students barely have chances to speak during a 45 minutes class. In order to improve the elementary students' verbal abilities, we create verbal fluency tasks. The figure shows one concrete example of our VFTs. Teachers use a mobile app to select VFTs from a bank and assign them to students. And the students are encouraged to think aloud, speak out their entire thinking process, not just the answer. Parents will take video clips when students are thinking aloud, and the video clips will be automatically collected and then graded by teachers. The disfluent score not only depends on the occurrence of interregnum words like I mean, but also consider long time silence out of logic sentences. The entire educational design of VFTs is highly recognized by teachers, students, parents, and educational scholars. However, it brings heavy workloads to teachers. In China, generally, there are 50 students in an elementary class, and the teacher holds 4 classes on average. A VFT video clip is about 2 minutes. From our survey, grading VFTs brings 10 hours extra workloads to teachers. In order to leverage the effectiveness of VFTs and reduce the grading workloads, we developed Dolphin, a verbal fluency task evaluation system, which is able to automatically evaluate VFTs from both phonological and semantic perspectives. This is the overall workflow of Dolphin. There are two sub-workflows. In the top sub-workflow, when a VFT clip arrives, we extract its audio track. The audio track is then sent to a prosodic feature extractor and our self-developed automatic speech recognizer. We extract prosodic feature and linguistic feature from ASR output. Then we combine these features and use a DNN to learn an effective representation for each clip, and then predict the phonological fluency by a logistic regression. In the bottom sub workflow, we first obtain pre-trained embeddings of both question and ASR text. After that, we learn a multi-attention network based on transformers to compute semantic relevance scores. Finally, we use a combination heuristic to derive verbal fluency scores from phonological fluency and semantic relevance results. At first, let's talk about the phonological fluency score. We collected 880 videos from the second grade students. In each video, the students talks about how to solve a math problem. The task is to predict whether the student speaking is fluent or not. To obtain high-quality labels, we asked 11 teachers to annotate each video to reduce inconsistency. We extract multi-level features from both audio tracks and ASR transcripts, including word level, sentence level. Since labeled examples are limited, instead of training a discriminative classifiers on limited data, we transform original data into groups to increase the size of training data. Specifically, we randomly choose 2 positive and k-2 negative examples to form a group, and later feed these groups into neural network to learn robust embeddings. Different from traditional metric learning approaches that focus on learning distance between pairs, our approach aims to generate more difficult scenarios that considers distances between not only positive examples but negative examples. We train a deep neural network on the generated groups and maximize the conditional likelihood of the one positive example xj given another positive example xi. At the same time, we minimize the conditional likelihood of one positive example given several negative examples. The total loss is taken over all the training groups. The model projects the samples from the same class to the adjacent positions and maps the samples from different classes to the positions far away from each other. Finally, we get the embeddings of all samples and train a logic regression model to predict the phonological fluency. But after a detailed study on teachers manually grading cases, we observe some naughty students fool our phonological fluency scorer by talking about completely irrelevant topics, such as answering different questions, casual live recording, even voice from TV. This is a real case from our system. We can see the teacher asked the primary school math question, but the student's answer was to read a song lyric. The students can read fluently, but it made no sense, since the student was not answering the question at all. So that's why we proposed a semantic relevance scorer here. Here is the overall structure of our model. We use bold lowercase letters for vectors and bold uppercase letters for matrix. We use subscript to represent the vector index, which is the index of word in each sentence in most cases. We also use superscript to represent the category of vectors. Our framework is based on the recently developed transformer architecture. It dispenses with any recurrence and convolutions entirely. It is built upon four crucial layers. From bottom to up, we use self-semantics extraction layer to collect all contextual sentence information from the pre-trained water embeddings. In the interactive semantic extraction layer, we use a cross-multi-way attention mechanism to extract the semantic relation between student answers and VFT questions, in preparation for comparing their semantic similarities at the next step. Then we design the integration layer to aggregate the matching information from cross-multi-way attention functions to a presentation vector with self-attention pooling method, and the final prediction layer to convert the extracted relevance features to a relevance score. The model is trained end-to-end, and we use cross-entropy as our loss function. We evaluate the effectiveness of the two scorers. For phonological fluency scorer, we compare our approach with several strong baselines that learns embeddings with limited data. LR is a logic regression model trained directly on raw features. For our approach, Siamese net, triplet net, and relation net, we extract learned embeddings and train the logic regression model on the embeddings for fluency classification task. The result demonstrates on the advantage of our approach in both accuracy and F1 score. For relevance score, we observe that our model outperforms all the baselines. We argue that this is because our model is able to effectively capture the semantic information between student and reference answers. Our approach not only aggregates sentence information with transformer block, but matches words in both question sentence and answer sentence from multiple attention functions. We also conduct online A/B experiments. In Dolphin system, automatic grades are given to teachers, and the teachers have the option to switch to manual grading model. We enable Dolphin for 183 elementary teachers from Hangzhou and Xi'an cities for half a year. The total number of weekly graded VFT assignments is about 80,000. In summary, 92% of teachers enable the Dolphin automatic grading functionality. Among these enabled subjects, 87% of the automatic gradings of VFT assignments are accepted. We also conduct a questionnaire-based survey about teachers' Dolphin usage experience. The teachers participated are asked to give satisfaction ratings from 1 to 5. As we can see, teachers are pretty positive on this grading tool, and the overall satisfaction ratio is very low. Automatic grading tools are a double-edged sword. They greatly reduce the burdens of repetitive grading workloads for teachers, but they could mislead students and sweep students' problems under the carpet. So, we suggest only use them for skill practice instead of entrance exams. Moreover, we design policies and heuristics to mitigate the misleading risks. First, we ask both the teachers and the parents to randomly check one result in every 5 VFT assignments. They're able to report the wrong grading immediately from the mobile app. Second, when the grading tool gives 3 consecutive low ratings to a child, an alarm will be filed to the corresponding teacher, and the teacher is required to check all recent ratings. In this paper, we present Dolphin, a spoken language proficiency assessment system for elementary education. Dolphin provides more opportunities for Chinese elementary students to practice and improve their oral language skills. In both offline and online experiments, the results demonstrate effectiveness of Dolphin in many metrics, such as accuracy, system usage, user satisfaction rating, and so on. That's all of my talk. Thank you very much.